So, as I mentioned, since the rest of my tutorial activities have nothing to do with your quiz, so I'll record a separate video to finish my tutorial. But for now, I want to focus on your quiz that's coming up on Thursday. And my plan is that we'll do some past quiz questions, especially the ones that were created by Marina when she was a coordinator. So we'll do some of the past quiz questions, and then I will do some past exam questions. And I think that's it. And after we're done, you guys can stay and do, I don't know, video chat and study together. I'm not gonna end the meeting, so you can still stay here after, but I might leave because I have a lot of work to do. Anyway, let's start. So the first question, let's try this. Yeah, a page. So let's try this question. It's a quiz question from last, so 2020 winter. 2020 winter, you guys and them, you guys, as I think some of you might know already, you guys have literally identical problem set. So I suppose it's gonna be similar. So one, prove that the following pairs of sets have the same cardinality. And they ask you, do not use the Schroeder-Bernstein theory. So you cannot use the theory. That will make your life much easier if you can use it, but you cannot use it. So basically you need to come up with a bijective function mapping from one to the other. The set, natural number, and s, which equals to x is a real number such that x squared is a natural number. Okay, so this is the first one. Part B, the interval 0, 1 and the interval 0 to infinity. Okay, so I'll give you some time, try to work on those two questions, and we'll take them up. S is basically all the integers, right? No. Nope. But you need to be careful with S. When I was marking this question, most people got S wrong. The set S, most people got it wrong. That's why they lost mark. So be really careful about your S. Basically, if you get it right, then you should be able to get the correct answer.
Sorry. Just I just want to make sure that I understand this correctly.
Let's see.
Hello?
Oh, are you talking? I muted every. Okay, now talk again.
Oh, yeah. Can you hear me now?
Yeah, I can hear you now.
Okay, I just want to make sure. Since I mean, if somebody doesn't know it already, it's just gonna slow them down. Set S is basically like the integers without zero, sort of.
No.
Okay, I'll give it a try.
Yeah. Someone said -1, -2, 2, -3, 3. No.
But it's also like let's say square root of 2. It's like the square of that is in the naturals.
Yes, you are right.
So
So
this is like the correct way of doing it.
yes, you're close. It includes square roots of something. Yes,
And zeros.
square root of 2 is an element of S. 0 is not an element of S.
Oh no, I mean like excluding 0. My bad.
Yes, excluding 0. So my suggestion is first you list out the elements of S in some pattern, okay, and then you try to come up with a bijection from there. You need to have the correct S to get the correct answer. Integers including 0 and square root, excluding 0 and square root of all the natural numbers. No. Close enough, but no. I see this might be a tricky one for you guys. Rationals, no. You can have irrational numbers like square root of 2 as well, right? Also, it doesn't really include all the rational numbers. This is easier than you think. Square root of all the natural numbers. I think you guys are missing something. Karen Dip is right. You can have negative square root of something as well. Positive and negative square. Yeah, square root. Okay. Let's take it up since you guys are. Yes, you're close or almost correct. So, your S, what is your S? Okay? S is a real number such that x squared equals to natural number. So x squared equals to natural number. The first natural number is 1. What? So we have x squared equals to 1. What does that give us for x? So the first one we have x squared equals to 1. So our x could be what? Okay, 1 and negative 1. X squared equals to 2. What do we have? For x. Square root of 2. Anything else?
And negative
Negative
square root.
square root of 2, exactly. Okay, and when x squared equals to 3, what can your x2 be?
The same as like above, or am I missing something?
Square root of 3 and negative square root of 3, and so on. So basically, you can get your s is actually 1, negative 1, square root of 2, negative square root of 2, square root of 3, negative square root of 3, oops, negative square root of 3, and so on. Well, square root of 1 is just 1, right? Okay, so this is your s. Now you want a bijection that maps from natural number to s. So there are two ways to do it. One, the first one, you can use the arrow mapping. Okay, so you can have, let's say, we construct I'm gonna change the color to show that this is the actual proof. So we construct a bijection from natural to s as below. So we can have, this is your natural number, which has 1, 2, 3, 4, 5, 6, and so on. And then you can have your s, which will be negative 1, 1, negative square root of 2, square root of 2, negative square root of 3, square root of 3, and so on. And you map 1 to negative 1, 2 to 1, 3 to negative square root of 2, 4 to square root of 2, 5 to negative square root of 3, 6 to square root of 3. Notice that the order in this case is really important. So you cannot do this. You cannot do 1 square root of 2, square root of 3, square root of 4, square root of 5, and so on. And at some moment you come back to negative 1, negative square root of 2, negative square root of 3, and so on. You cannot do this, okay? You cannot do this. This is not allowed. Why didn't we include square root of 1? Square root of 1 is 1. That's why 1 and square root of 1, they're the same. That's why we didn't include it, because it's here. 1. Okay, here is the thing. When Mike Polywook, which is another prof coordinating this course, he did not accept this arrow diagram as a formal proof. Okay, so when he was coordinating, this is not acceptable. But for the past 2 years, when Marina's coordinating, she accepted this proof. So when Marina's coordinating, this is fine. Now is Marina coordinating, so I suppose this is fine as well. I personally think this is totally fine. I don't know why Mike didn't think it's not a formal proof. But if you want an explicit function, you can do this. So another way to do it is we can write an explicit function. So let's say f map from natural number to s, and let's define it to be f of x equals to negative square root of x plus 1 over 2 if x is odd, and square root of x over 2 if x is even. So this is an explicit function. So you can write this as well. Okay. Okay.
Sorry.
Answer the questions. Yes, yes, yes.
So either one of those will count as a full solution, right?
That's what I suppose. I would say try to aim for an explicit function. So this is better, but I think Marina accepts this as well because for the past few years, when she was coordinating the course, this is an acceptable proof. So you can get full mark for writing this as well.
So even if I can't come up with, at least for what you're assuming right now, I'll check and talk to the professors again. But as of right now,
Mm-hmm.
if I sort of see some sort of pattern and I list it as something from n to, or the other way around, let's say for this case, from n to some set,
Mm-hmm.
and it sort of makes sense because like the elements sort of match, then it would be fine.
Well, I think so. As long as like as long as you enumerate it like in this way in certain order, insert a
Mhm.
pattern, and for example, when I say what does 8 map to, and you can clearly tell me what 8 map to because of the order. You arranged it in certain order that everyone knows that which number maps to what, then it should be fine.
And would it be okay if I write it as the first element from, like, let's say n is 1, then s would be 1. And
So you
I
mean
mean,
like 1 negative 1 square root
yeah,
of negative? Yeah,
it would be
that would
okay.
be fine. Yeah, that would be
Okay.
okay. Yeah. Okay,
Okay,
let me
thank you.
answer the questions in the chat. Can we let the function f from s to n, and then it's f of x equals to x squared? Hmm, no. You know why it's no? If you do that, it's not a bijection. You need a bijection function. So if you do that, negative 1 and 1 they map to the same element 1, which means it's not injective. Since it's not injective, it's not a bijection function. So you only show that s, the cardinality of s is less than or equal to natural number, or the cardinality of natural number. So you need a bijection. Okay? That's why you cannot do that. Oh, let's see. Any other question?
I had a question.
Mhm.
So what you're saying is if you're using the arrow diagram, like how would you like more formally write it? Is this enough like for a proof
This is
or
enough. If suppose Marina accepts arrow diagram, then this is enough.
okay? Thank you.
Any other question? Um, I think you should confer with Marina. but I think she'll accept it. Okay. Yeah, I think she'll accept it. Also, I think Dario would accept it too. Any other question? Okay. Also, why don't we include a number like 2, for example? Well, you do have number 2, which is right after this. So here you'll get 2 and negative 2 right after negative. So here, x squared equals to 4 will give you x equals to 2 and negative 2. So it's right after square root of 3 and negative square root of 3. Okay? Any other question? Okay. If no question, part B. So part B,
Oh, sorry for. I just have a quick question. Do I have to sort of prove that something is a bijection, or just showing that just
good
saying it
question.
is?
Good question. I think, what do I say? I think if you write this, okay,
Hmm.
then it's clearly a bijection because it's like one element mapped to one element. You don't need to prove anything. But if you write this, then I think you need to prove it's a bijection.
Right, then the arrow technique it is then.
Yeah, so then you need to show that it's injective and surjective because
Yes.
it's not obvious that it's a bijection.
Hmm.
Mhm.
Yeah.
But
Thank
if
you.
you used, if the function you used or something, for example, a linear function or identity function or e to the power of x, like those functions, I suppose you don't need to prove it. But just to be safe, because I know some TAs are really picky about this, so just to be safe, you should always prove whatever the function you come up with is a bijection. But another thing is that you might not have enough time to do this. So I suggest you to leave it first, finish your other questions, and come back to prove it if you have extra time. Okay?
Yeah, and the professors are going to be marking the exams, right? Not the TAs.
Yes, the professors are marking the exam.
Okay.
TAs marking the quizzes, assignment, test, but the professors are marking the exam.
Yeah. Okay. Thank you.
Okay. Okay, part B, the interval 0, 1 and the interval 0 to infinity. So we want f. This, you can have multiple functions for it to work, but here is a obvious one. We can have f of x equals to 2 over pi arc10 of x. So arc10 of x looks like something like this. It passes the origin, where here is pi over 2 and negative pi over 2. So what I did is I used a function transformation to make it be I mean, this is from R to R. So G R to R, G of x equals to arc10. I mean, the function I drew is this. So what we want is we only want this part. So from 0 to infinity is this part. I want to use function transformation such that here is not pi over 2, it's 1. So I multiply by 2 over pi. So do function transformation, this function would look like something mm, like this, where you don't have this point, and here the asymptote is 1 instead of pi over 2. So this is one of the function you can do. Anyone has any other function you have in mind? How do I come? I just told you. I just told you because I know arctan looks like this. Oh, one thing. One thing I want to say. One thing I want to say. You should know the graph of those functions for you to come up with this faster, okay? Once you know the graph, it's much easier. I see one of you said x over x plus 1. That's a good one. I used that as well. So you should know e to the power of x. You should know what this look like. You should know what long x look like. You should know just leave it here. Oops. You should know something like x over x plus 1. Yes. You should know this function as
For
well.
this, any exponential function will work here, as long as you sort of flip it.
Well, there are a lot of functions that can work. That's why when I marked this question when I was TA in this course, and that's why it took me a long time to mark because everyone gave me different examples. So there are a lot of questions that works. Sorry, I got a call. Hello. Okay. Oh. Uh, just give me a second. Gonna talk to my sister. Okay. Okay. Question: can we use Cantor's diagonalization theorem for this question? Uh-huh. I How would you use it for this question though? I'm not sure how would you use it for this question. Do I need to show formal proof or drawing is not a proof. Drawing is not a proof. Graph is not a proof. You need the function. Okay, you need a function. You need an actual function. Okay. X over x plus 1 includes all of 0 to 1. Yeah, I think it includes all the 0 to 1. So another one, because the graph looks like this. It's a continuous function. It's gonna be something like this as well. Well, the original graph should be something like this. And you only want 0 to infinity part, so it's only this part. This function should work as well. Yeah, it's not integers. It's a weird number. Since it's 0 to infinity, so you can have those real numbers. Okay, another trick that I want to tell you is this. Might not be helpful for this question, but another thing is we know, for example, we know natural number and integers, they have the same cardinality, right? Sometimes they give you two sets, and sometimes they might be weird. Um, for example, they ask you to prove Q and S. So, for example, in this case, let's say S is still this S. So they want you to copy, paste Q and this S has the same cardinality. Then the bijection you have, it might be really complicated. Okay? It's not easy to come up with a bijection directly between those two. So what you can do is you know that this is countable. It has the same cardinality with natural number. Okay? So we know that cardinality of natural number equals to the cardinality of Q, which means that there exists a bijection between those two. So we have F mapped from natural to Q. So we know a bijection. Now you can just come up with another bijection between natural and S. So this is, let's say this is G, sorry. Let's say this is G. And you come up with another function F, which is a bijection between N to S. Then you can use composite of those two because we know the composite of bijection. So bijection composed bijection is another bijection. So you can use a composite of those two functions to show that those two have the same cardinality. So it's another trick. So for example, when we have F, which is mapping from natural to S, and this is a bijection. So to prove those two have the same cardinality, which function do we use? Actually, it would be easier if I change this to Q map to N. Yeah.
You could just use sort of like, there's a rule that says that if you have like one function that's injective from, let's say, I don't know, Q to N, then if you have another function that goes from N to Q that's also injective, and I think it has to be an inverse, then Q and N have the same cardinality.
No,
Oh, sorry. Yeah, it
that's
says.
not true.
Um,
That's not true. You have to have a bijective function.
yeah,
Injective.
I meant to say that
So
if
in this case, you don't even need to do that. In this case, if I change G to Q to N, you can just have F compose G. Then F compose G is from Q to S. And since G is a bijection, F is a bijection as well, then F compose G is a bijection. So this function would be the function that you have to show those two have the same cardinality. Does that make sense? Any question? So I just wanted to say that sometimes when they give you weird things, and if it's easier to, if you know it's, if you know the cardinality of one of them, for example, Q, we know that it has the same cardinality with natural number, or for example, this we know it has the same cardinality with real number, then you can use this technique. Okay, so use a composite of two bijections to come up with your bijective function if you have problem to do it directly. So that's like a trick to do it. Any question? Question? Okay, I suppose you guys are good, so let's try this one. It's from the same quiz, and it's question 3. Decide if the following statement is true or false. So true or false, and then you need to prove or counterexample. The statement is if A is a subset of B where A is countable and B is uncountable, then B minus A is uncountable. Okay, so this is a statement. You need to determine if it's true or false. If it's true, you need to provide a proof. If it's false, then you need to give me a counterexample. Give you some time to think about it. It's not that easy to do it. At least for you guys, I don't think it's an easy question. Okay.
Ling,
Yeah.
you mentioned that if you were using the function
Mm-hmm.
and not the arrows, then
Mm-hmm.
we have to prove that it is in fact bijective.
Yes.
But you haven't done it for the previous one. Is it just to save time?
Yeah, because I'm pretty sure you guys know how to prove bijective already, right?
Yeah. I just want to make sure.
Yeah, I didn't do it because I think you guys know how to do it already.
Yeah.
But you should do it. But as I mentioned before, you should finish your other questions first. And if you have time, you come back and prove it's bijective. Okay? Because you might not have enough time to do it. And I'm not sure if they will deduct a mark from you if you didn't show it's bijective. So you finish your other questions first and then you come back.
Okay. I'm pretty sure. Like I googled it a few days ago,
Mm-hmm.
and I saw that there's a way to show bijectivity by mutual injection. Not
Yeah,
sure.
but you are not supposed to use it.
Uh,
Yes, that's
it's
one of
easy.
the session. Yes, I know, but you cannot. You're not supposed to use it. It
Is
makes
it
your life easier, but they want you to do the traditional way.
is it something you will learn in like uh the following years, or just it's
Well,
just easy and useless?
well, it's not useless. It's pretty useful. It's a really strong theory, but they don't want you to use it because that makes a lot of questions much easier, and they want you to make sure you know how to do.
Um, I sort of used it for half the questions I solved. All right, then.
Okay,
Okay,
continue
thank you
with
for
the
clarifying it.
question. Continue with this question. I'm gonna get my food. I'm so hungry. I think if people used in problem set, I didn't deduct mark because they didn't say you cannot do it. But for the quiz, they might tell you do not use the theory, then you cannot use it. Also, anything that's not being taught in class, you cannot use them either. Okay?
So there's no point in asking the professors, right?
Yeah, because if it's not covered in class, then you cannot use the technique.
All right.
Oh, my food. What did you guys eat for dinner? Sit, right, sit. Not no dinner yet? You should eat. You can go grab food and come back. Like right now, I'm trying to eat. Oh, it's 6:20 a.m. Okay. Fish and chips. Okay. I, oh, international students. Why are you guys here? Just sleep. It's recorded. You can come back and watch the video later. The reason I recorded everything is because I don't want international people in other countries, I mean in other time zone, need to wake up early and attend the tutorials and stuff. I repeat anything you watch. I do that a lot too. Yeah, 2 times speed. Yeah, I do that too. Also, like sometimes when you play music videos on 2 times speed, it's like we're into a new world. It's pretty fun. I can't open my food. Or 0.75. Yeah. I tried that too. It's pretty fun. Okay, do you guys think it's true or false first? True? Yes, it is true. Okay, now try to prove it. Ugh, can't open this. It is true. Okay, so if you think it's false, it is true. So we don't need to try to find. Brownie, go away. Go away. Go away, Brownie. It's not your food. Oh, it smells so good. Yeah, that's not a proof. Examples are not proof, unfortunately. If A is a subset of B, does that mean X is in A and B? Oh, if X is an element of A and X is a subset of B, then it means X is in B as well. Oh. That's basically the definition of subset. How about using contradiction? I don't think you need contradiction though. We have to somehow say there is no bijection between N and B minus A. Mm, actually, Nicholas is right. I think you need contradiction for this one. So you suppose B minus A is countable. Oh, smells so good. Do you guys want to see what I'm eating? I'll turn on the camera to show you. Okay, just give me a moment. Not sure if you guys can see me. Can you guys see me? Oh, you can see me, but you cannot see my food. Let me turn off the background. There we go. And here is my food. You see? It's fish, barbecue fish, and with some vegetables on the side. It's huge, so I don't think I can finish it now. I'll probably save some for tomorrow. Now it's like a live stream of me eating. I feel bad for. Also, if you have some idea of how to do this, you can annotate on the screen and we can have a look. So we can collaborate with each other and try to finish this. So I just use no. No. You can say A has the same cardinality with natural number, but being uncountable doesn't mean it has the same cardinality as real number. For example, the power set of real number is also uncountable, but its cardinality is strictly greater than the cardinality of real number. Can you do something like B equals to B minus A union A? Sure. A is countable, okay. I think you're on the right track. You're on the right track. So keep if B minus A is countable, would that imply A is also countable? Exactly. That's exactly what we need to do. Nice. That's nice. Nice. Good job. Okay. Basically, that's what you need to do. But you're missing something. You're missing something because you need to show, you need to prove something first. You need to prove if we have two distinct countable sets, then the union of them is also countable. So you need to prove that first before you do that. Okay? Alright, so anyone want to write down the proof? I'm eating, so I don't want to write. Anyone want to write for me? Write it on the screen and let's see if your proof is correct. Well, we have the idea already. So first you need to prove if we have two distinct countable sets, then the union of them is also countable. No, it's not given. Unfortunately, it's not given.
To prove that part, like the initial like countable thing, like can we like assume since we know A is countable, we can write it as like A1, A2, and so
Yeah, you can
on.
do that.
Similarly for B minus A, B1, B2, and then union would be a certain set, and then we can use the thing I just said.
Mm-hmm. So can you write that down?
I'm on a mouse, but I'll try.
Okay, try to write that down so that everyone else can see it too. This proof is really important. The proof of the union of two distinct countable sets is also countable. This question was tested in almost every single exam. 102 exam. This are variations of this, so make sure you know how to do this, okay? The question that, okay, let me type it up. Prove two distinct the union, the union of two distinct countable sets is also countable. The thing in blue, I typed it up. This is what you need to prove for this question first, and the proof is really important. Yeah, I can type instead of draw. You can do that too.
You guys can't read it. Sorry, I'm using a mouse.
Mm, you didn't show it though. You need to show why. Let me draw. You need to show why this is countable.
Okay.
Because this is a union of two countable sets, you need to show why it's countable.
Do I need to use like an example or something?
No, not example, the proper proof. Anyone want to help out? Sarah, do you want to write it down? Okay, I think I'll erase what's on the board now because Sarah might need more space. Anyone has any question of this idea of writing B equals to B minus A, union A? Okay, no questions so far? So basically, we write B as this. Then if we're saying that if B minus A is countable, A is countable, then the union of them should be countable as well. The union of them is B, so B should be countable as well. So that's a contradiction. Now our next step is showing that the blue part, okay? This part, we need to show this part. I'm gonna erase what's written here. And someone write down the proof of two distinct countable, the union of two distinct countable set is also countable. Also, if you cannot use the arrow diagram, what explicit function would you use? You need to think about that as well, just in case you are not supposed to use the arrow diagram. Mm, close enough, but it's not done yet. You need to show the actual bijection. Whoever is typing this, okay, that's close, but you need to show the actual arrow diagram, show the actual bijection. So what map to what? Yes, from N to A union B. Yeah. Mm, not really, Sarah, not really. You need to show the bijection from natural number to A union B, not A to B. It's don't erase what you have in blue. Leave it there. So I want you to add one more step here. Before you reach a conclusion, I want you to add one more thing. So I want you to draw the arrow diagram and show me what map to what, which is really simple in this case already. Okay? And here A union B. Yes, exactly. I'm full already. I still have so much left. Yes, and one of you wrote the explicit function as well, so I'm back. There we go. Exactly. That's what I wanted you to do. Okay? So when you do this, this is better. Yes. There we go. So when you try to prove this, you either use the explicit function as Nicholas mentioned here, or you use this arrow diagram, which is right here, or you use this to show that. Let me write something down. Okay. So here we're showing that two distinct countable sets. So you either use this or use the f mapped from, oh, it's overlapping from here. So f mapped from natural to A union B, where your f of x equals to a, not this a, small a of x plus 1 over 2 when x is odd, and b of x over 2 when x is even. Okay, so this function will give you whatever we have here as the arrow diagram. So this. So you either show this arrow diagram or you show an explicit function to show that this is also, so the union of two distinct countable sets is also countable, and you use what we said before. You write b, you write b as b a minus b union a. We know those two are distinct. We know this is countable. We suppose this is also countable. That's gonna give us b is also countable, which is a contradiction. Do we need to prove the function is bijective? Good question. Again, as I mentioned before, if you use the arrow diagram, then it's obvious that it's a bijective function. If you use this, then you might need to show it's a bijective function. But as I mentioned before, you only prove it when you have enough time. Okay? If you don't have enough time, then don't even bother, because they might not even deduct mark from you. Okay? Only do it when you have enough time. Any other question? Is this clear? Oh, another thing I want to mention is that you should show that this identity is true as well. Okay? Yes. It's usually better to use in quizzes since it's very time limited. Another thing is if you use this, you need to show this is true as well, because I don't think anywhere in the textbook show you this is true. So we need to give a short proof of this is actually true. So we need to prove this first as well, which we're not gonna do it here since I think everyone knows how to do that already. Okay? Any question? If no question, let's do another question. This is number 2 of last winter's tutorial. So here, determine whether the following x are finite or infinite. So determine if they are finite or infinite. If x is infinite, prove whether it's countable or uncountable. Prove it's countable or uncountable. If it's finite, then they want you to find the cardinality of x. Okay? Part A, you have x equals to the set of mn in z cross z such that m plus n equals to 2. Part B, you have x equals to the power set of negative 1, 0, 1, set of negative 1, 1, and the empty set. Okay, try this question. Hmm, okay, so is the first set infinite or finite? Anyone? Infinite, okay. Is this countable or uncountable? Countable. Okay, cool. So now we reached an agreement that you need to map, you need to find the bijection. Again, as I mentioned, you know that natural number is countable. You know that integers are countable. You know rational numbers are countable. So when you do the bijection, you don't necessarily need natural number. You can use rational number and integers as well. Okay. Whichever makes your life easier, you use that one. And also remember this is a Cartesian product. So you need, it's not just a single element, it's a pair. also, for part B, is this countable or uncountable? Oh, no, not countable. Is it infinite or finite? Part B. Finite. Okay, cool, cool, cool. At least we know this, so we can get partial marks. This is infinite and countable. This is finite. Let me see. We have -1 on, so I'll map each to. I do not suggest you to do that. Sarah, I do not suggest you to do that, because in this case, you might have like -1, 3. So 3, -1, and -1, 3. So it's hard to enumerate it in certain pattern. So it's better for in this case, it's better that you come up with an actual function, like explicit function. Because listing them in this case is not a good idea, because it's hard to use some pattern. Since it's finite, it's uncountable in this class. In this class, the definition of uncountable, they said it's infinite set. So finite, we don't think it's countable, and we don't think it's uncountable either. It's just finite. Let's just call it finite. Well, okay. How many elements does this X have? I think this is an easier question, so let's do that first. How many elements does this power set have? 2 to the power of 5, exactly. Okay, so when you write this, you need to say, since this set has 5 elements, copy, paste. Since this has 5 elements, its power set X should have as 2 to the power of 5 elements. Okay. One thing I want to mention is when I was marking this question, a lot of students calculated wrong. 2 to the power of 5, they calculated wrong, and I didn't know what to do, because they got 2 to the power of 5, but the final answer they gave to me is actually wrong. So if you don't know what 2 to the power of 5 is, you leave it to be 2 to the power of 5. Okay? You should write it as equals to 32, but if you don't know that 2 to the power of 5 is 32, then don't put 32 down. Okay? You just leave 2 to the power of 5, because usually each mistake will minus 0.5. So you don't want to make any unnecessarily stupid mistake. So if you don't know what this is, then you leave it as 2 to the power of 5. It always base 2 infinite. It's 2 to the power of n. So let's write it down. So if x, the cardinality of x equals to n, which is finite, then the cardinality of the power set of x is 2 to the power of n. Okay, this is a short review. I did that in last tutorial, but just remind you, you should know this as well. Let's go back to part A. Anyone have a function in mind? I'm gonna map from natural number, no, for integer to x, and my function is f of x equals to x minus 2 and x. And then you prove it's bijective. Any question? You can have many other functions as well. This is just one example. Okay, this is just one of the function that works. And I think it's a really easy function that works. Proof injective surjective is easy as well. So anyway, any question? If not, I want to do divisibility a bit. So here is a question. Oh, for that question, yes. If we plug in 4, we get 6. We plug in 4, get, what do you mean plugging 4 get 6? Which one? Yeah, oh, you plug in 4, then 4 minus 2 is 2, then it's 2. Oh, I see. There is a mistake, huh? It's 2 minus x and x. Yes. Nice catch. It's 2 minus x and x. Or x 2 minus x. Doesn't really matter. How do you prove bijectivity is for Cartesian product? Um, I did that in the last review, and I did that in a few videos, so check that. Okay. Okay. Divisibility, really important ones. Okay, let me go back and show you. Make sure you know how to do those. The ones I did in tutorial, really important. How to find GCD, really important. Okay. Using Euclidean algorithm, thus to find the GCD of two number, really important. Also, this is pretty important as well. Okay, use Euclidean algorithm backwards. This is important as well. Another thing is this is important as well. They might not just give you something simple like this. So they might ask you to show another number as irrational. They might ask you, for example, show that square root of 3 plus square root of 5 is irrational. Or they can give you something really weird. Okay? So be prepared, I would say. Actually, they never give you something like this, but since it's online, things might change. So I suppose they might give you. There's really low chance that they'll give you something like that, but it's still possible. The question that I want you to try is this one. It's not from any past test or anything. Mm, let's try this. Prove that if there exists xy in z such that ax plus by equals to 1. Your a and b are integers as well. Then GCD of AB equals to 1. are not both 0. Okay, try this question. Okay, so someone said for the square root of 3 plus square root of 5 problem, could we prove square root of 3 and square root of 5 separately? Well, you need to prove that separately, but what do you do after? Because irrational numbers plus irrational numbers doesn't guarantee the sum is irrational as well. Okay, because irrational numbers is not a field, which means if you add them together, you don't have the closure axioms. So add them together doesn't guarantee an irrational number. So you need to think from there. Think from there. Also try something like prove square root of p is irrational, where p is a prime. If a and b are both even, will the GCD be 2? Yes. Oh, doesn't well, GCD is at least 2. It doesn't mean that it has to be 2 because they might have other greatest common divisor. Well, 2 would be a common divisor, but it might not be the greatest common divisor. Isn't this prime numbers? What do you mean this? Which this are you talking about? I'll be back. GCD of it. I'll be back, guys. I'll be back. Okay, I'm back. Let's see. GCD. Wait, why is it on this page? Okay, GCD AB equals A. Wait, GCD AB equals to 1. Oh, it's not prime number. It's called A and B are relatively prime. Doesn't mean they are prime numbers. It's just called they are relatively prime.
So they basically have no common divisor, sort of.
Their common divisor is 1.
Yeah.
Yeah.
I mean, other than one.
I'll give you a hint. You need to use Benzo's identity. So if you don't remember that, let's go back. So you need to use this. Okay? Let me put it there. I'll write down my proof while you guys continue thinking about it.
Doesn't this just like straight away sort of proves it?
No. No. This gives you if GCD of two numbers equals to something, then you have this. But what I want you to do is if this, then GCD equals to this. It's a backwards. Does that make sense? So this
Yeah.
is saying that if GCD of AB equals to some number, then we have MN equals to MN are integer such that we have this. But this is saying that if we have this, then the GCD is 1. So they are different.
Yeah. Okay.
Suppose there exists xy in integer such that ax plus by equals to 1. Now I'm gonna use by results identity. Since we know uh, we know by this identity, we know that GCD of AB divides A. Oh, we don't need the identity. Never mind. Just realize that we don't need this. We know that GCD of AB divides A, and GCD of AB divides B. Okay, since this is true, we have that GCD of AB divides AX plus BY. Actually, I'll write down more steps because this is not trivial. GCD of AB divides A will give you GCD of AB divides AX. This will give you GCD of AB divides BY. So if you add them together, GCD of AB should divide that too. Any questions so far? This chapter is so trivial. Well, after this, we'll go back to cardinality. I just want to do one question from this chapter. This chapter is pretty easy, I agree. Okay, so this means that GCD of AB divides 1 because AX plus BY equals to 1. Okay, then this gives us GCD of AB equals to 1 because only 1 divides 1. Okay, any question? I hope this is simple. Simple? Easy? No question? Hopefully no question. If no, I think we'll do one more question and that's it. Let's do a question from Mike's problem set or Mike's. How did you get GCD of AB equals to A? No, not equals to, divides AX. Divides AX. Because it divides A, so it should divide AX as well. Yeah, not equal to, okay, divides. Question 1. Oh, this is basically the same. Oh, yeah, this is basically what we did before. I'll write down the question, but it's basically what we did before. I'll still write it down. So let A be a subset of R, be countable. Prove that R minus A is countable, which is basically what we did before. Okay, this is basically the question we did before, like this question. They're almost the same, but this is a homework question from last year, and there are multiple ways to prove it. Oh, this question. Let A, B be sets. Prove that if A is a subset of B, then the power set of A is a subset of power set of B. And then explain why we can conclude that if A equals to B, then the power set of A equals to the power set of B. Okay, try this question and check more. or so. 3. Well, A and B are two sets. Prove that if power set of A is a subset of power set of B, then A is a subset of B. And we can conclude if this, then this. Okay? This is for power set. A few more. I don't know if we have time to do all of them. But here is one more. This is a good question as well. 2 and 3 will do one of them. Which one do you guys want me to do? 2 and 3 will do one of them. No, we only have time to do one of them. Do 3? Okay, let's do 3. You guys try 3 and I will write down question 4. Wait, it's defined B to be this by constructing a bijection. F then map to A to B. Okay, try those. Three and four, okay? Try those two. Yeah. Bonnie? Felix just sent question for on Discord. Oh, nice. Well, then I'll take it up. Well, we can do all three. All three questions he sent, we can do all of them. But this review session is gonna be super long though, because it's been almost 2 hours already. You can leave anytime you want, okay? You don't have to stay here. Wow, sleep doesn't matter if I can get more marks. Well, if you don't sleep to study, I don't think you can give you more marks. Because you need a good sleep to do well on your quiz as well. Okay, okay, cool. You sleep like 10 hours. I was like that too. And I don't know, everyone just asked me to to fix my sleep schedule, and everyone asked me to be healthy. So I'm trying to be healthy now. Oops. Yeah, I'm trying to be healthy. So I sleep around 12 o'clock now. Recently, I got a lot of work to do. I can't sleep with finals keep you awake. What course are you guys taking? Oh yeah, what course are you taking and when are your exams? Math 137 is down. Oh, because it's a full year course? What's UTM 115? Oh, nice, nice. Intercultural communication. Why is it called UTM? CIN. I suppose that's cinema something? Yeah, cinema, yeah. Movies. Oh, you guys are all first year students. Oh, there is a course that's really, really, really bird. Basically, the easiest course I've ever taken. It's called Religion 206. I don't know if it's still that easy, but when I took it, was so easy. Basically, I think it's called Introduction to Buddhism. Um, well, a lot of religion courses are really easy, but this one is so easy because basically all the lectures are not related to what's gonna be tested. So the lectures, he's just talking about random things that you don't need to listen. So basically, you show up to the lecture to write the weekly quiz. The weekly quizzes are multiple choice questions. What you need to do is you read the textbook. So every week he will assign 2 to 3 pages of textbook for you to read. But the book is really small. It's like, let me find a textbook that's around that size. Do I still have the text? Oh, I even have the textbook. Yeah, so this textbook, see, as you can see, it's really small. So every week he assigned 2 to 3 pages for us to read, maximum 5 pages, really. So after you done your reading, the multiple choice, also the weekly quizzes, will be based on the pages you read during that week. Do I remember the professor's name? I can search it up later. But um, every week the multiple choice, the weekly quizzes is based on the assigned reading, and also yes him, yeah. Also, all the quizzes, including the final exam, it's not cumulative, which means after you read the pages you can forget about it. You don't need to remember anything after the quiz anymore. I'll talk about that later. So for this course, you have weekly quizzes which are based on the textbook, reading, assigned reading, and then you have one essay. You have the whole semester to write the essay. It's like 20% uh, of your final mark, and then you have one final exam. The final exam has nothing to do with the quizzes you had before, and it's new readings. So he'll give you some other readings for you just to read for the final exam. So after you read that, you write the final exam. The final exam has one essay as well, but it's really simple. It's really easy. The essays, well, I'm really bad at writing, but I still got 4.0 on the essays. So don't worry about that. That course is so easy. Oh, the other bird course, I for humanity courses I took linguistic 204. Yeah, linguistic 204 is really easy. It's online. Yeah, it's really bird. This course. It was like online since the very beginning. It's really easy. Yeah, well, based on the waitlist, you should see that this is an easy course.
Liang.
Mm-hmm,
I'm doing question 3 right now, and I'm not sure why, but whenever I see the power set stuff, I
mm-hmm.
mean, other than um, the fact that the set and its power set do not have the same cardinality, and like the subset part, I'm not sure like how to sort of go about solving this or proving this.
Let me tell you what you need to know for power sets, especially questions like this. The key is that you need to realize this. If a set, or if X is an element of A, then, oh, actually no. If X is an element is a subset of A, then X is an element of power set of A. And if X is an element of power set of A, then X is a subset of A. Those two statements is based on the definition of power sets, but if you know this, you basically can do any questions they gave to you. Okay? For example, question 3 here. So, question 3. We have power set of A is a subset of power set of B. So let's assume that power set of A is a subset of power set of B. What we need to show is we need to show A is a subset of B. So since we want to show this, remember how do we show this? We pick an arbitrary element from this. So let X be an element of A. That's our first step. This means that the set that has X is a subset of A. Does that make sense? So far, does this make sense? No, 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 Brownie, no. Sorry, guys, my cat and my dog are fighting again. Brownie, come here. You leave him alone. Brownie, 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 Brownie. Hello? Brownie, come here. Brownie. No, don't fight. Don't fight. Don't fight! Brownie, come here. Okay, I'm gonna stop then. Okay, say hi to my cat, and then I will put him away. No, 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 Brownie, go away, go away. Okay. Ronnie, go away. He doesn't like you. He doesn't like you. Can you just accept the fact he doesn't like you? Okay, done. So basically my cat my cat doesn't like my dog, but my dog always wanna play with my cat. So every time he approaches my cat, we just start the fight. Anyway, go back to this question. Since this is a subset of A, remember if X is a subset of A, then this is an element of the power set of A. So this will give us this, the set of X is an element of the power set of A. Okay, this is a by definition of power set. Power set. Alright, and also we know that this is true. So since this is true, we know that this, the set of X, is also an element of the power set of B. This is because power set of A is a subset of power set of B. Okay, any questions so far? Question? No question? Okay, if no question, read this. If X is an element of power set of A, then X is a subset of A. So here, this is an element of power set of B, which means that this is a subset of B. This is again by definition. So this is a subset of B. This is by definition of power set of B. Okay? Since this is a subset of B, then X must be an element of B. So X is an element of B. Now we show that if X is an element of A, X is also an element of B. So therefore, A is a subset of B. Any question? Does this make sense? I'm gonna drink my soup. I'm so thirsty. Question? Guys, question. Anyone has any question? Bye, Nikita. All good. Okay. Yeah.
Sorry. So for the, like in general, the sort of problems with the power sets,
Mm-hmm.
the Cantor's theorem does like apply, right? It can be Cantor's. It's basically I've mentioned it before. It's
Yeah,
so
yeah,
if
yeah.
okay, yeah, all right, thank you.
Cantor's theorem is not that useful in proofs. It gives you like a fact, but it's not that useful in proofs. It's useful when you, let me think. It's useful when you need to compare something, like the cardinality of two sets.
Like yeah, if I have to, yeah, that's what I want to say. If I have to sort of find the cardinality of something, then
Yeah,
if I can prove that something is
Yes,
a power set.
in this case, it's not useful.
Mm-hmm.
Mm-hmm. Okay,
Yeah,
let's
okay.
do question 4. Question 4. Let's try this. So we need to prove those two sets have the same cardinality by constructing a bijection F that map from A to B. So basically what you need to do is this. So we have B be collections of all functions. Okay, so I'm gonna write each of functions separately. So proof for an element A in X, I'm gonna let FA be 1 map to A. Oh, excuse me. So this is, thank you. This is what we need to do. So I pick an element from A, and this function that map from 1 to A. So basically, you can only map 1 to this A. We call this FA. Okay. Be the function defined by fa of 1 equals to A, because the domain is just 1, so you can only map 1 to A. So let's do that. And then now let's define our function. This f, which map from A to B f of A equals to this function f of A. Why do I do that? Because the B here is a collection of functions. So when you do this mapping, your image is always functions. So that's why we need to define this first, so that we can make this bijection. Okay, any question? Question. And also you need to prove that this is a bijection. So then prove f is bijective, which I'll leave that to you guys. It's bijective. So you prove that it's injective and surjective. Any question?
Hello.
Yes.
So do 1 and A have the same cardinality?
1 and A.
Instead of 1 and A?
No. A and B have the same cardinality. 1 and A don't have the same cardinality.
Okay.
No, this is just, I'm just saying, every such function that map from 1 to an element of A, we define it to be f of the element. And the, okay, B is a function, is a collection of functions. So in this case, I'm doing that fa. Let's write this instead. Suppose your A is something like A1, A2, A3. It doesn't need to be countable, but I'm just writing it for you to understand. It doesn't need to be countable. I'm not saying A is countable, but I'm just saying that A1, A2, A3, whatever. This is really confusing because you might think A is countable. So let's say let A be in A. So you pick any element in A. Since B is a collection of all functions that map from 1 to A, since your domain has only one element, which means it can only map this element to one other element, to another element. Okay? Because it's a function, you cannot map this to two different elements. So you can only map this to one element in A. Does that make sense? Because your domain has only one element. Yes, okay. So basically, this B is a collection of functions. So it's what I'm saying is that I'm giving every single function a name. If it maps to A, I call it f of A. If it maps to B, I call it f of B. Does that make sense? And you might have infinitely many functions in your B. Okay? You can have as many as you want. It depends on how many elements of A you have. The whole reason that they have the same cardinality is because your domain has only one element, so it can only map to one element in A. So the number of functions in B depends on the number of elements in, like, depends on how many elements of A has. So what I'm doing is that I'm defining that if the function map from A from 1 to an element A, then I call it f of A. If it maps to B, I call it f of B. So in this case, my bijective function, that big F, capital F, mapping from A to B is at f of A. So A is the element mapped to the function that I named with this A. So that's a bijective function. Well, you need to prove that it's bijective, but does the function now make sense?
What else would you have in B? So you have f of A, f of B. Would you have f of C?
Well, not necessarily f of C, but it's f of the f of something, which this something is the element of A. So if your A is like A1, A2, A3, A4, then B is gonna be f of A1, f of A2, f of A3, and such things. Does that make sense?
So what would come after f of B?
It depends on what's in your A. I don't want to write anything down because A might not be countable. If it's not countable, I cannot list them out. Does that make sense?
Yeah.
So let's say if your A is like a natural number, if your A
Uh,
is a natural number, then this will be f of 1, f of 2, f2, f3, and so on.
can I ask a question?
Yes.
So just to make sure that I understood it, like how the function works.
Mm-hmm.
Basically, the collection of functions, which is B,
Mm-hmm.
is basically because A can technically be anything. Like the lowercase a can be anything. It's
Yes.
basically something from 1 to like any possible value, and
Yes.
we're
It's
listing all those
from
possible
1 to
values.
any element in A.
Yeah, like
Any
yeah.
of the element in A, but you know that it can only map to one. Like for each function, you know that it can only map to one element in A.
Okay, yeah.
Yeah, basically that. Yes. Okay. No other question? I think we should end here too. It's been 2 hours, and I don't want to keep you for longer. If you have any other question, you can email me. I'll type my email address here. Okay, so this is my email. If you have any question, you can email me, but I think it will end here. Okay? Bye,
Could
everyone. Yeah.
could you please scroll up a bit, just a little bit? Yeah. Okay. I just wanted to see the question again. Yeah. Thank you.
We need to prove that f is a bijective function, okay? I didn't prove it, but you should prove it if you see something like this.
Mhm.
Bye, everyone.
Yeah.
Good
Bye
luck
bye.
with the quiz.
Thank you.